Hello and welcome to the first video in Unit 10, the structure of the atom. In this video we're going to look at the names and symbols of some common elements, look at subatomic particles and their properties, what are quarks, and what is the atomic model. Do you remember what an element is? It's a substance with atoms that are all alike. It's made of only one kind of atom, and every element has a symbol that is recognized worldwide. And we're really lucky because these happen to be in our alphabet, these symbols. We're going to look first at symbols of common elements that begin with only the first letter of the name. H represents hydrogen, B represents boron, C represents carbon, P represents phosphorus, O represents oxygen, S represents sulfur, and F represents fluorine. Symbols of common elements that begin with the first two letters of the name are right here. Li for lithium, Be for beryllium, Ca for calcium, and notice that the first letter is capitalized always, and the second letter is lowercased always. So aluminum, silicon, bromine, helium, and neon. There are also some symbols of common elements that begin with the first letter of the name and another important letter, not necessarily the second letter. That would be magnesium and chlorine. Here are some symbols of common elements that are derived from a foreign language, so they have nothing to do with letters in our own language. And A is sodium, K is potassium, Fe is iron. You might have heard of ferrous metals. Those are metals that contain iron. Cu is copper, Ag is silver, Au is gold, and Pb is lead. So if an element is matter that's composed of only one type of atom, what is an atom? An atom is the smallest particle of an element that retains the element's properties. Atoms have smaller particles called subatomic particles, and there are three of them we're going to look at: protons, neutrons, and electrons. The protons and neutrons are contained in the nucleus of the atom, and the protons are the subatomic particles that have a positive 1 electrical charge. Neutrons are the subatomic particles in the nucleus that are neutral. They contain a 0 electric charge. And then outside the nucleus, we have subatomic particles called electrons. And they occupy the space surrounding the nucleus, and they have an electric charge of -1. So are the protons, electrons, and neutrons that make up the atom the smallest particles that exist? Well, no. Scientists have found that protons and neutrons are composed of smaller particles called quarks. Electrons, though, are not made of smaller particles, but so far scientists have confirmed the existence of 6 uniquely different quarks. A particular arrangement of 3 of these quarks produce a proton. Another arrangement of 3 quarks produces a neutron. So how do scientists study quarks? Well, in order to study quarks, scientists accelerate charged particles to very, very high speeds and then smash them into protons. These high-speed collisions make the protons break apart. There are 2 places in the world where this research takes place. These facilities use giant machines with electric and magnetic fields that are able to accelerate, focus, and collide these fast-moving particles. One of these locations is the Tevatron at the Fermi National Accelerator Lab in Illinois, right here in the United States. Another facility is the Large Hadron Collider. It's in Geneva, Switzerland, and it has even greater capability for producing greater forces. And the ultimate goal of both of these research laboratories is to discover new particles. You can notice the tremendous size of both of these laboratories. to give you a better appreciation for the amount of collaborative work that goes on in making these discoveries, the sixth quark was very difficult to discover and took a team of nearly 450 scientists from around the world to discover it. And it was because the tracks of that sixth quark were very hard to detect, because only about 1/1000% of the proton collisions performed indicated the presence of that sixth quark. So there was a lot of collaborative work all around the world that goes into discovering these very tiny subatomic particles. Let's take a look at the evolving atomic model. We know that scientists and engineers use models to represent objects or ideas that are very difficult to visualize or picture in your mind. And the atomic model has changed a lot throughout the years. Around 1400 BC, a Greek philosopher named Democritus proposed the idea that atoms are tiny particles that make up all matter. It was kind of the first atomic model. However, Aristotle, another philosopher, he disputed that idea. He said, no, matter's uniform throughout. It's not composed of tiny particles. This incorrect idea was accepted for about 2,000 years until another man named John Dalton came along in the 1880s, and he presented evidence to suggest the existence of atoms. Here are the tenets of John Dalton's atomic theory. Matter's composed of particles called atoms, that those atoms are indivisible and indestructible, that atoms of a given element are the same, and atoms of one element are different from atoms of another element. He also proposed the idea that atoms combine in fixed ratios to form compounds, and that in chemical reactions, atoms are either separated, combined, or rearranged. These were really big ideas. They allowed scientists to finally express chemical reactions in quantitative terms, and to allow them to use chemical symbols and chemical equations. So in 1904, a man named J.J. Thomson proposed a plum pudding model of the atom. He actually started thinking about what is the atom made up of. And his idea was that, I don't know what plum pudding is, but you could think of it like a chocolate chip cookie atom. His model was of an atom that was positively charged, and embedded in that sphere of positive charge were these little chocolate chips, perhaps you could think of it, electrons that had little negative charge. In 1911, the idea of a nucleus existing was a new idea that was proposed by Ernest Rutherford. And then in 1913, just a few years later, Niels Bohr proposed the idea that there are electrons traveling in fixed orbits around that nucleus. Now, not all of these models are accurate. Some of the ideas are. There is a nucleus, indeed. That's our modern model now that we look at. However, the idea of fixed orbits is not really what is happening. Let's take a look at the modern atomic model. In 1926, modern atomic theory proposed the idea that, yes, indeed, there is a nucleus, but electrons are not orbiting in fixed patterns or orbits around that nucleus. Instead, there is what we call an electron cloud, and that indicates regions where electrons are likely to be found. As you know, most of the atom is indeed empty space. This is not drawn to scale, but this would be an electron cloud model of the hydrogen atom, and this cloud indicates regions where the electron for the hydrogen atom is likely to be found. If you're looking for some advanced proficiency ideas, here are just a few research models that are used in other fields. What about the wooden sphere atom model that Dalton constructed? Some of his models are on display in the Science Museum of London. He was very ridiculed for his idea of atoms on the basis that atoms could not be seen, so they didn't exist. Brainstorm some other things that exist but can't be seen. Also, are you interested in subatomic particles? What are leptons and bosons? Any other ideas you have? I look forward to what you come up with, and we'll see you in class.